Evan, are we up to you? Oh, you went. Armando, what did you went? Santiago, what do I start at? Always start at 0. Okay, what do I do?
1800.
Go up 1800. Next, Eric,
Go down. Sorry, go across.
go across, nothing's happening. Then, I'm not gonna keep turning around, okay? Whoever's next, go.
Then just keep going.
Going down, you mean, right?
So of course.
Because it's 1500?
Yeah, so go down to 300.
Good. Okay, Elliot?
You go straight across.
Chris?
Go down diagonal.
Go down diagonal. What do I go down to? So let's see, this force equal to base times height. The base is 10, the height is 250, so it must be 2500, right? So what do I go down to if I'm at 300? 2200. And then Andrew?
Go to 0
Right, and why do I go to 0?
because of the 2200.
Because of the 2200. So this is my check. I'm down at 2200, I know I have to go up to 2200 and I close at 0, which is great, because I'm supposed to be at 0. So Haley, what would you design this beam to withstand in shear?
2400.
Great. Did everybody hear that? I mean, sometimes with math, we think of positive and negative, right? And a positive 1800, you might say, is greater than a negative 2200. But it doesn't matter if this beam is being broken down or up. It's still experiencing a shear of 2200. I need to make sure that it can withstand 2200. Yeah.
And it's not 2,500 because, that was my answer. So you're at 300 and you actually go to 0,
Right,
which is the difference of 50 and
right. So where does it experience 0 shear? It does right here.
Right there, that one.
And that's what I just remember from memory, it's 1.2. You have to do the math. Chris?
Unlike that last one, I thought it was 0 because on both sides of
Yeah.
it was equal. But on this one, you have like
Oh, okay,
significantly more.
okay. It is 0 because it's crossing the 0 shear. That's why it's 0.
But that one's crossing the
Yeah, but at the same point, so at this point, it's experiencing a shear of 1.25, right? Okay, so sorry if I just said yes to something that I didn't understand your question. So right here, it's experiencing a shear of 1.25. All along here, it's 1.25. It experiences a shear here. But when you hit this point, it experienced a 1.25, but then it goes to 2.5. So I think the answer is that you subtract them. I have to,
That makes
investigate
sense.
that, but I'm pretty sure what you have to design it for is 1.25. And then all along here, it's experiencing a shear of 2.5, 2.5, and then here, it's experiencing a shear of 0. So it's crossing the 0.
So then why wouldn't it be 2200 minus 300 what it experiences at that point?
Because at that point, at this exact point, it is only experiencing 0. At this exact point, it experienced 1.25 and 2.5. Like just to the left of this point, it experiences 1.25. Let me look at whether this is 0 or not. I don't think it is.
I think you're right.
Yeah, that makes sense then. But
Yeah.
just at that one point. It's
At that one
experienced,
point. And it may be that maybe it is, like just to the left it's 1.25 and just to the right it's 2.5 and maybe in the maybe it is 0 there. So let me try to figure that out, but in the end, it doesn't really Does it matter?
So
It doesn't matter because in the end, you wanna make sure that you're designing this whole beam to withstand the greatest shear, which is 2.5. Well, I guess what does matter is if it fails there, how are you gonna analyze that, right? If it fails at this point, are you, could we say it's a zero shear, so therefore it couldn't have had a shear failure? Let me look that up, all right? I don't know how I'm gonna find it, but.
that would be a whole, is that like an actual specialty within civil engineering or engineering where you analyze failures? and how
At
some
each
fail?
point, yeah,
Is it like a special job or something?
yeah, but it also has to do with, we're just talking about loading. I mean, it could fail because material is not homogeneous, or there's a
Okay.
crack somewhere, or, you know, there's a whole bunch of other things. But in terms of loading, we're just talking about loading right now. Yeah.
So when do we actually generate these drawings? When do we start doing this kind of analysis?
When you have to design a beam,
This is a
when you're
design-
designing a structure and you have to choose a beam, you have to do this.
This is a design technique.
Yes. I don't know if technique is the right word. I'm not sure. I would maybe say analysis, maybe technique is the same word, maybe they're synonyms, I don't know. I was never that good with vocabulary. Okay, let's do this one. Where are we? Yeah, Paul, so we started 0, then what happens?
Okay, so, we're going to the moment diagram.
Nope, we're still doing shear, we didn't do any moment diagrams yet.
Okay, so we have.
So
the
is there,
diagram.
so just to go back, notice, every time there was a vertical load, there was a direct vertical change in this shear diagram. Here, there was not